everyone. Thanks for joining me today. Has anybody heard about OWASP Top 10? If not for Kubernetes, for applications, security, so. Three of them? Okay. So let's talk about what is OWASP. OWASP is an open world application security project. It's an open source project which do their research and then share the security recommendations in different fields. So it can be on Kubernetes, on your applications. They do have some controls. And the main purpose is to make sure that it's secure and all the top threads that can be related to that ecosystem is something that they publish. So today we're going to talk about what are the top 10 security recommendations that OWASP is recommending. And this is for somebody who has cluster running in their production, and they should at least follow, if not all the compliance, they should at least follow these top 10 recommendations. First one is insecure workload configuration. If you think about Kubernetes is not secure by default. That means when you install a cluster, configure a cluster, it doesn't come with all the security aspect by default. You have to do some configurations. You have to do a bunch of other things to make sure that you're not deploying any insecure workloads. So a couple of ways to do that is you can have a bunch of policies. You can have something called as admission controller. You can either deploy a admission controller or either you can use the native Kubernetes admission controller and deploy policies. Kubernetes also have recommendations like pod security policies and what you should deploy to make sure that you're checking these workloads. A couple of the tools that are in CNCF is one is Kyverno. Of course, I'm from Kyverno, so I will be a little biased, but there is also OPA, and then there is Kubernetes native validating admission controller that you can also use. The second one is overly permissive RBAC configuration. What does that mean? Is using the default cluster roles that Kubernetes have, or using wildcard permissions, or deploying Helm charts which already have cluster roles in it, and then you deploy that application. So you're basically deploying the cluster role as well. You're using verbs like escalate, bind, impersonate, which is pretty much escalating the permissions that a developer should have. You're patching on namespaces, you're using cluster aggregation. All of these are examples of overly permissive authorization. So what you're doing is, or if you're using any of this, what it means is you're providing a developer, an engineer, or a user on Kubernetes overly permissions that they really do not need. And that can be exploited, and then further there can be a security threat. The best practice is always start with least privilege. That means always start with just read access and then pick one by one the permission that is needed. Couple of approaches that you can take is there's something called as JWIT, just-in-time token. That means anytime when you need somebody to have access to the cluster for troubleshooting or for something that has gone wrong and they need an access to the cluster, you should use JWIT. The third thing you can do is you can use OIDC, and there's something called a short-lived token for OIDC, so they can get short-lived token for the session, and then they can get access to this cluster. Now, if you go in each of this recommendation, it itself has a solution of its own. Like if you talk about JWT, you can do it using different ways. OIDC, there are a bunch of OIDC out there in the market. So each of the solution is something that you have to design and understand how it fits in your ecosystem. But these are like 2-3 approaches that you can do. Couple of things where Kyverno can also fit in here is many few people know that Kyverno is not just used for validating your configuration. There is something called as mutate policies, generate policies that you can do using Kyverno. That means it can generate new resources or it can mutate existing resources. So you can provide any trigger and you can do JWT approach or solution with the help of Kyverno as well. Third one is secret management failures. Now this is when you have improper handling of secrets, you have secrets in your config map, you are using secrets in environments, you have it in GitHub, or even just secrets in general. We know that secrets are just base 64 encoded in Kubernetes. That means anybody can decode them and have access to the secrets. So the way to just make sure that that doesn't happen, or the best practice to make sure that you're addressing this control, is managing secrets centrally. So you can use something like Vault, Conjur. There are a lot of open source tools out there in CNCF. These two are just an example. Have all your secrets centrally stored there. Make sure they're encrypted. That's second best practice. And third is make sure you rotate them periodically, because you don't want a secret sitting there for years and then every application have access, and then now the exploitation starts from there. So 3 best practices: keep your secret centrally and make sure you are encrypting it, and then rotate it periodically. Vault or Conjur is one of the tools that you can use, but of course there are many out there. 4th is lack of cluster level policy enforcement. What does that mean is, think about, you have clusters, but you don't have clusters just on-prem. You have clusters in Azure, you have it in AWS, you have it in on-prem. You have all these clusters across your environment, and you don't really have a way to enforce the best practices that you want your developers, the engineers to follow. You don't have a way to actually deploy the compliances, the port security policies, make sure you have the labels, all those best practices. There is no central way that you're managing the policies, because your clusters are kind of scattered in all the ecosystem. The way you can mitigate this is make sure all your policies are centrally managed. GitOps is one more way to manage this. You can use tools like GitHub. You can use tools like Argo CD to deploy them. All of these are, again, open source tools. You can have all the policies centrally in your GitHub, where all the policies are stored centrally, and then you can allow Argo CD, Flux CD, or any CD to deploy it on your cluster. That way, you're not kind of scattering these policies. You're not manually deploying it each one by one. You're not trying to understand which are following the best practices, which are not. You're centrally kind of managing all these policies. Anytime there's a new best practice that your security team talks about, anytime there's a new compliance that your security team talks about, you create a policy, you put it in Git, you apply it everywhere. So you have a way of centrally managing it and very organizing it, rather than, this cluster has this, but this cluster doesn't have the best practice and things like that. Now, one thing about, as I was saying, policies, when it comes to policies, you have 3 tools. You have Kyverno, you have OPA, you have Kubernetes Native Admission Controller. Once you deploy policies, for example, using Kyverno, you will have something called as policy reports. So you can deploy these policies using Kyverno either in audit or enforce mode. Audit is a soft check, that means it's not going to block anything, but enforce is like a hard check, where it's going to block every of your pod which is not complying with those policies. So for all the audit policies, you'll have policy reports, and you can export all these reports in Grafana or some observability tool. So you really know now what you're doing is you're not just applying the policies, you're centrally managing it, you're deploying it across cluster, you have a dashboard that tells you which cluster is failing the best practice and which cluster is not. So that is something that if you're running today in production, and if you're on good size and you want to scale further, having a centralized policy enforcement method helps you to enable that scalement for your clusters. 5th is missing network segmentation control. Now, I think we kind of know what does that mean. If you think about today, in your organizations, or you might have some environments where you're following multi-tenancy. That means you have one cluster and you have different applications sitting in particular namespaces, and you have a multi-tenancy model. The thing about Kubernetes is it allows your application to talk to other applications sitting in a different namespace. That means it doesn't have the network isolation that you need for your customers, for your clients, if you're following a multi-tenancy approach. So the way to that is deploy namespaces. Kubernetes have something native that you can apply. It's a YAML. You can deploy network policies in every namespace and make sure these applications are not talking to other applications. You can use tools like Cilium, which is a CNI that can help you to provide those network isolations. And you can also use something called Calico. These are, again, open source tool. You can also use Kyverno. Kyverno can generate these network policies based on the trigger. So you can have a rule saying that every time there's a namespace created, create a network policy in that namespace. The 6th control is overly exposed Kubernetes component. What does that mean is, if you look at your cluster, and if you kind of like try to deploy a Kubernetes cluster by default, you might be tempted to have your API service endpoint as a public endpoint. or you can have a node which has a public endpoint IP. It is going to expose these endpoints to your internet. So you'll have overexposed cluster components. You'll have an API server which is exposed to the internet, or you have a kubelet endpoint which is exposed to the internet. So in Kubernetes, if anybody wants to talk to the Kubernetes cluster, the first thing they'll do is they'll hit the API server. Every time you do kubectl, you hit the API server, and that's how you go inside the cluster or access anything that you want to access. So the first thing is you also always have to make sure that your API is private. It is only trusting the network, the host that you want the cluster to trust. So make sure that you're not opening up these endpoints to public. Second is, cluster is not just built on cluster. Cluster is built on a couple of nodes that are underlying it. So if you have these nodes, make sure it's not public, make sure it doesn't have any public endpoint, and it's just not exposed out in the public. Couple of tools that you can use is something called as kubebench. You can run a kubebench. I think it's a stateful set or it's a job. You can run that and it will give you an entire list of all the components that are exposed, so you can use that. If you want to automate this, there's a tool called Kubescape. Again, these are CNCF of open source tools. And there's also Falco that you can use to just make sure your runtime security is all good. If you want to follow some authentication mechanism for your API server and restrict those, you can use tools like Teleport or Tailscale to make sure that all the time there is authentication happening. And the best practice, like making sure you have private endpoints, you have all the firewall rules required and stuff. The seventh one is misconfigured and vulnerable cluster components. Now, how is this different than the sixth one is, the sixth control was talking about you have an exposed API. That means, think about you have a house and you have kept all the doors open. So anybody can access the house, anybody can come in, come out, and they can steal something. This one talks about you have not configured the house in a way that it needs to. That means you don't have your air condition in a configured well, or you don't have your ceiling fan working well, or your walls are not good and stuff like that. Not only that, you also have some vulnerable things. That means you have kept some wiring out there so that anybody can touch it and they can get an electric shock or something. That's what it's dictating in Kubernetes language. That means it is probably the endpoints are not exposed. That means your clusters still have a door and authentication and everything, but it's not just configured. The components are not configured well. So a couple of things that you can do is, first of all, is here as well you can run kubebench. Kubebench actually runs and shows you how it's configured and how well it is not. One more compliance that helps is the CIS benchmark. Most of the controls over here actually parallel and matches with CIS benchmark. So if you're following CIS benchmark, you're pretty much following these controls, but you can run the CIS benchmark adapter and see if you're seeing any of those vulnerabilities there. You can use open source OS distributions such as Talus Linux. You can use Flatcar container that actually supports the container-focused OS distribution. If there's any time you have these patching mechanism, or if there is a new patch, if there's a new Kubernetes version that's out there, make sure that you patch it, make sure you configure it well, and make sure you run these adapters if you think that it's not configured well, because these adapters can run and tell you an entire report of what's happening in your cluster. The one last thing that I want to talk about this one is, very few people know that there is a long-term support for your Kubernetes cluster as well. So make sure that you don't have a cluster running at 1.29 or 1.27 kind of a version which is very old and it's not just supported, because anytime there is a new version that is released, it's released with all the security best practices. Third is, anytime there is because it's not just about the cluster, it's also about the nodes. So anytime you're using a Linux or you're using Unix, if there is a new patch available for that particular version, make sure you patch it, because there'll be some threats that are mitigated in those patching. So keep it up to date so that there is no vulnerability on the OS level, and run a couple of tools and see if your configuration is well. Broken authentication mechanism. Using certificates to authenticate, having your own authentication workflow, using, I guess, service accounts or long-term tokens for authentication. Those are all like creates leakage for your authentication. Couple of things that you can do is, as I said, using JWT is standard, using OIDC, enabling MFA for your clusters or any applications running on the clusters, and disabling all those anonymous access, default service account token, using certificates, because Kubernetes is weird when you have to rotate that certificate. Sometimes when you use certificate for authentication, it stays there for years. So anybody can use that certificate and again go back to your authentication. Or just building your own authentication mechanism, because you have so many tools out there. You can use OIDC, you can use short-lived token, you can use JWT. You can really take advantage of that rather than building your own authentication mechanism and then doing some leakage in there. So it's recommended and better to use the standard authentication workflows and not try something that is gonna broke or provide a leakage in the ongoing project. The last one is inadequate logging and monitoring. So awareness is key. If you're running your cluster and if you don't have any logging, any monitoring set up, that means you really don't know what's happening in your cluster. It's like you don't have any awareness, you really don't know what's happening, and it is not going to be very powerful. So one thing is making sure you have adequate logging. That is, in Kubernetes, you also can enable logging for your API server, for your scheduler, for your controller. There is, I don't think it's for controller scheduler, there is for API, then there is for audit. Anytime anybody does kubectl or talks to the API, you get that. So make sure you enable all the audits, all the things that you need for your cloud or your on-prem, and then have some node exporters, Prometheus, Grafana, there's Datadog, there's a lot of out tools for your monitoring system so that you understand what's happening in your cluster and what's not. So that's all. These were like top 10 OWASP Kubernetes that is recommended, and if you want to follow these compliances, you just have to do these 10 things. These are really basic. This is not very difficult compliance. These are something recommended by OWASP, and following this will just make sure that you're running your cluster secure in production. Thank you.